Good evening, everyone, and welcome to the Zeiss-Großplanetarium, a part of the Stiftung Planetarium Berlin. We are here tonight to do our English language star show, Starry Night. And this evening, we will be taking you through to see the fall-time sky and hopefully help you become more confident backyard astronomers. And we'll take a couple planets to look at and our moon as well to take a closer look at what's been going on in the news with them, as well as what we have to look forward to in the future. As you can see, we're coming to you again, once again, in your home. We're closed again for Corona. We're following all the rules here, keeping everyone safe, including you in your home. So with that, let's go ahead and start taking a look at our sky here in Berlin tonight around 10 p.m. All right, so the first thing that most people want to do when they go outside and they look at the stars is they want to get their bearing on north. And the best way to do that is to look for the Big Dipper, or at least that's what we call it in the United States, which is where I'm from. But here in Germany, we refer to it as der große Wagen, which is the large cart or wagon. And it has different names throughout the world. It's what we call an asterism. It's not an official constellation. There's only 88 official constellations, and that's determined by the International Astronomical Union. Anything that's not one of those official 88 is called an asterism. You can create your own asterisms, and what's interesting is a lot of cultures will share asterisms and just call them different things, but we will all agree that it is part of, in this case, an constellation called Ursa Major, or the Big Bear. Now, we know it's a little hard to see, so we're going to help you out here with your imaginations to hopefully see the bear a little easier. I'm sure that's what you were all imagining, but just in case. Now, if we take the front two stars of our Big Dipper, Merak and Dubhe, we can follow them. They guide the way to our pole star, Polaris, and that is the tip of the handle of our Little Dipper, or der kleine Wagen. And that, of course, is part of our little bear, Ursa Minor. Now, these constellations are circumpolar constellations, which means that they circle that pole star that's at the tip of the Little Dipper very tightly throughout the year, and that means that we can see them the entire year. That's what makes the Big Dipper so ideal for finding that North Star, and the North Star always stays in that spot in the north all night long, all year long, as long as you stay at the same latitude. So as long as we stay here in Berlin, that's where we will always find our North Star, and we will be able to get our bearing on north. Now, that, like I said, are the circumpolar constellations, but we have constellations for every single season. And then since we're in the season of fall, I'd like to take you to explore our fall-time sky. Now, as we start off with our fall-time sky, we're going to look for the Great Square of Autumn. And it's hidden a little bit in the stars, but you'll notice there aren't that many stars that we see inside the square. So that hopefully will help you find it compared to the other potential squares that you might find out in the sky. Now, once we have found the Great Square of Autumn, we're going to be able to find two constellations attached to it. The Great Square of Autumn is an asterism. But there's two official constellations, the first of which is Pegasus the Flying Horse. And the second is the Princess Andromeda. And the Princess Andromeda is actually really helpful to us in navigating our fall-time sky. So if we start at her head, we can work our way back 2 stars. We're going to go up a star, and then about that same distance again. And right about there, if you were in a dark enough area, you will actually see the farthest away deep sky object that you can without optical aid. So this is M31, the Andromeda Galaxy. And when I say without optical aid, that means you don't need a telescope, you don't need binoculars, you just need to be somewhere that's really, really dark, like in Brandenburg. And I don't mean that politically. But here in Berlin, obviously, that's not going to be ideal for seeing M31. But I have seen it as I've gone out into the Brandenburg area. You usually have to get about an hour to 2 hours outside the city before you're going to be able to see a deep sky object like this easily. Now, Andromeda will also help us find her mother, Cassiopeia. So the stars in her feet point us up to Cassiopeia, the queen. Now, near Andromeda's feet, we're going to see Perseus, the hero. And for those of you at home who have enjoyed the Percy Jackson series, yes, this is where we get a lot of that storyline from, as well as Percy himself, Perseus, the constellation, the mythological figure. Now, if we look under Andromeda, we are going to find another constellation that is part of our fall-time sky, and that is Cetus, sometimes called Cetus the whale, also called Cetus the sea monster. And here I think he does look a little bit more like a monster than a whale, to be sure. Now, all of these constellations that we have here are part of one epic story. So most of the constellations that we have in the Northern Hemisphere, their names come to us from Greco-Roman tradition, the ancient Greeks, the ancient Romans. And because of that, their myths are very much tied into these constellations. The myths also have been adapted, so you may actually recognize some of these names as well, just from, for example, Clash of the Titans. If you've seen that, you're probably somewhat familiar with these names at least. And again, like I said, the Percy Jackson series as well. So how do we get to this epic story? Well, we're going to start our story with Queen Cassiopeia. And as you can see, she is looking at herself in a mirror, admiring herself and how beautiful she is. And you can think of her a little bit like the evil queen from Snow White. She was obsessed with how beautiful she was, and she wanted to always be more beautiful than anyone else. And one day, she went and bragged that not only she, but also her daughter, they were more beautiful than any of the nymphs of the sea. Well, one of those nymphs happened to be the wife of Poseidon, god of the sea. And as you might imagine, Poseidon did not appreciate Cassiopeia's comments and decided that she needed to be taught a lesson. And so he sent Cetus out of the sea and into her village, where he began to run amok. And Poseidon told Cassiopeia the only way that she was going to make Cetus go away was to sacrifice her daughter Andromeda. And so without any other choice, Cassiopeia had her daughter Andromeda chained to a rock at the seashore and left as a sacrifice for Cetus. And that's why we see Andromeda up there with chains on. Now, fortunately for Andromeda, while all of this was going on, Perseus was out on a quest. He had been sent to slay the Gorgon Medusa, the woman who had hair of snakes, and if she looked at you, she would turn you to stone. Well, Perseus had finished slaying the Gorgon Medusa. He had saved Pegasus, been imprisoned inside of Medusa's neck. I cannot make that up. That's actually part of the myth. And on his way home with Pegasus, he happened to look down and see Andromeda at the seashore, chained to this rock. And he flew down wondering what was going on. And as Andromeda began to tell her tale of woe, the monster approached to bring her into the sea. But Perseus was a quick thinker, and he swiftly drew the head of Medusa from the bag he had it in at his side, showed it to the monster, and turned Cetus to stone, saving Andromeda's life. Well, after this, the two had already fallen madly in love, and Perseus wished to marry Andromeda, and so he asked Cassiopeia for permission. Unfortunately, Cassiopeia said no, Andromeda was betrothed to somebody else. But Perseus gently reminded her that he had just saved Andromeda's life and he had the thing that did it in the bag next to him, and hoped that she would reconsider her answer. Unfortunately for Cassiopeia, she did not reconsider her answer, and so Perseus turned Cassiopeia to stone. This enabled Andromeda to be free. The two of them were married. Perseus and Andromeda lived happily ever after in a new area of Greece that they ruled over. They had many children, and their children continued to rule over that area of Greece for generations to come. Now, this is my favorite story that you will see in the nighttime sky as far as the Greek myths go. And part of that is because it ends happily. A lot of the Greek mythology does not have a happy ending, but this one, for the most part, does. Now, the story's not quite over. You see, Poseidon was very, very upset that Cassiopeia basically got away with what she had said and didn't really get punished. And so he asked his brother Zeus, who was the king of the gods and the lord of the sky, to place everybody involved in this epic adventure in the sky. And for most of them, this would immortalize them and be an honor forever. But for Cassiopeia, the queen, this was not an honor. This was an insult, because everybody would be able to look at her and know of her folly and her selfishness for the rest of time. Now, as you can see, there's definitely a moral associated with this story as well, which was why the Greeks used the stars to help them tell their stories, help them entertain them, each other. This was a way for them to also pass on their morals and values to the next generation. Now, this area of the sky is also known as the sea. And we're going to actually move just a little bit to see the sea a little better. And you might be thinking, a sea? We're looking at the sky. Well, this area, you'll see very quickly why it's referred to as the sea. We are going to now also bring out Aquarius, the water bearer, and Pisces, the fish. And so, as you can see, Pisces, Aquarius, Cetus are all water-related constellations. Unfortunately, it's below the horizon. One of my favorites, Capricornus the sea goat, which is basically a mermaid goat. That is also considered part of the sea as well. Unfortunately, that has set and is not part of our sky right now. You can also consider Pegasus a part of the sea. And again, you might be wondering why, considering Pegasus is a flying horse. But in Greek mythology, Pegasus is actually the child of Poseidon, god of the sea. And so therefore, Pegasus is often still related with the sea. Well, we are starting to head out of fall here in the northern hemisphere. It's getting colder and colder as we head towards December. Next month, we will have our winter solstice. We're not quite there, but I do want to give you just a little bit of a sneak peek as well at our fall time sky, or excuse me, our winter time sky. We already did the fall. And so the first one that we're going to look at is the constellation of Orion the Hunter. Very, very popular. One of the easier constellations to find in our wintertime sky. Famous for having the belt of 3 stars, and he is surrounded by 4 stars making a rectangle that are his shoulders and his feet. So, and then at the top, his right shoulder, you'll be looking at the left side. That is the star Betelgeuse or Beetlejuice. It's a red star, and it was very popular at the beginning of this year because it's been dimming. It's still continuing that, and that's something that we are still keeping our eyes on. Now, Betelgeuse does tend to do this every so often. It's dimmer than it's been before. So, of course, everybody would like to see it come to an end because that's something that is very rare for us to see. But it's so far away that it would take a very long time before we would be able to see that result. So we may be seeing a lead up to it, but we also may begin to see it really brighten back up to where it was before. Now, Orion, just like Andromeda was our guide to the fall time sky. Orion is our guide to our winter sky. And so if you follow his 3 belt stars straight up, they are going to lead you to kind of an orangish star, and that is the eye of Taurus the Bull. That is Aldebaran. And Taurus the Bull, there he is, fighting Orion the Hunter and protecting the Pleiades star cluster, or M45, there on the back of his shoulder. So you may also know those as the 7 sisters. And since this is the wintertime sky, we are going to leave that for another time. But that is a little bit of a sneak peek into our winter sky. And as I mentioned, you are able to start seeing these appear in our skies here in Berlin now. So this evening's actually fairly clear. So if you are in the Berlin area, I do highly recommend after the show to go outside and look for them. But this is not all that we have to look at. We have our moon that we would like to visit, and we also have Mars that we would like to take you to. And we have a pretty good reason for why we would like to do this. Both of them have been in the news quite a bit recently, and there was some big excitement for the moon. So we're going to go ahead and leave Berlin now and fly out into space. So we pass our Big Dipper. And there we are. We've launched away from the Earth. And what we're looking at now is Europe, how it looks right now at night. And as you can see, we can see all of those city lights. You can really tell where certain cities are. You can make out the Nile in Africa. And that's because that's the best place for people to set themselves up and live. So it looks cool from space, but because of that, it also is the reason that we have a hard time seeing our night sky. So to have the safety and the beauty of the lights, we also lose the beauty of our real night sky. So unfortunately, that is a trade-off that we have to make. But fortunately, we do have dark sky sites that are preserved, and hopefully we'll be finding more of those, or more of those will be established as time goes on. Now, I just mentioned water, the Nile, and that's exactly what I'd like to talk to you about next. So at the end of October, the Sofia Flying Observatory made a pretty cool discovery. So this is what Sofia looks like. It's a joint project between NASA in the United States and the German Aerospace Center. So that's pretty exciting that it is, for me at least, that it's a tie between my two countries. And this particular observatory is very special because it flies at altitudes up to 45,000 feet. This is a modified Boeing 747, so it goes much higher than any that you might fly in. And the telescope, because it can fly so high in Earth's atmosphere, the telescope can actually reach above 99% of the water vapor in Earth's atmosphere, which allows it to get a closer look and a clearer look at deep sky objects. Typically is what it looks at. But in this case, NASA wanted to see if it could help us answer some questions about the moon. So we're going to go ahead and fly to the moon now and take a look at where Sofia targeted. And if you're wondering, NASA is a big fan of acronyms. So we have Sofia, which is the Stratospheric Observatory for Infrared Astronomy. And the tool that it used to do its observation is called Forecast, which is the faint object infrared camera for the Sofia telescope. Now, Forecast was able to lock onto a crater on the moon, specifically Clavius crater. And this crater is where Sofia was able to actually identify water particles, H2O. And this is very exciting because this is the first time that we've been able to really get a for sure lock on water particles on the moon in the sunlight areas. So before the observations that were done, unfortunately the data wasn't clear enough, and it was hard to tell if we were actually finding H2O or if we were finding OH, hydroxyl. And it's a chemical relative of water, but definitely not something that we can use to help us as humans. So we're zooming in a little bit now on the Clavius crater. And that is where Sofia found those water particles. Now, when we say it found water, we're not talking about a whole lot. It found roughly the equivalent of a 12-ounce bottle of water in about a cubic meter of soil across the lunar surface. So that's not a lot, but it's a start, particularly as we look towards landing the first woman and the next man on the moon. And that is an international joint venture. And we're looking to do that in 2024. So that could actually be very helpful for them to be able to study that and see if it's feasible for us to actually build a base on the moon, which would then in turn help us to launch to Mars. And speaking of Mars, I'd like to also take a look at our red planet and our next door neighbor, because Mars has been in the news quite a bit, and something rather exciting happened with it. Now, you might have actually noticed Mars out in our night sky. It's been very bright. Even here in Berlin, it's been very, very noticeable. And perhaps you're wondering why it's more noticeable than other times. And that's because Mars is coming out of opposition. So Mars oppositions happen about every 26 months. And every 15 or so years, oppositions can occur within a few weeks of Mars' perihelion, which is when it is closest to the sun. Now, when that happens, we can get what's called a perihelic opposition. And that is when Mars and Earth pass the closest to each other. So what we're looking at now, Earth and Mars's orbits, and you're indicating now. And that was when opposition happened. So opposition was on October 13th. But we still get to enjoy those effects for a while. And that's why we continue to see Mars so bright in the sky, because Earth and Mars have made their closest passes with each other. This is also why we launch vehicles to Mars when we do, because it's much better to launch them when they're going to be closer to where they're flying, in this case, Mars. So with that, we're going to actually go back in time a little bit. We had to go forward to show you the crater on the moon. So the good thing about planetariums is that we're like time machines, or the TARDIS, if you will, and we can travel through time and space and bring you along. So as we approach Mars, we're actually flying along basically with some of the spacecraft that are on their way there right now that were launched back in the summer. And we'll talk about those in a little bit. As we get close to Mars, you're going to notice that there's 2 orbital markings around it. And those are Mars's moons, Phobos and Deimos. And that means fear and panic, respectively. And they are the children of Mars, who is the god of war. So they all go together pretty well. Phobos and Deimos are asteroids that Mars captured from the asteroid belt. So whereas our moon, we think, was formed during the protophase due to some impact and that time period forming it, Mars stole its from the asteroid belt. So it was not created from Mars. I want to take you a little closer to Mars, though. We're not going to bring you this far and not take you in closer, of course. And the first thing that we're going to visit is Olympus Mons. Olympus Mons is the largest mountain and volcano in the solar system. So even though Mars is a little bit smaller than the Earth, it has some of the largest geographical features on it in the entire solar system, which is part of the reason that we enjoy studying Mars so much is the geography. Now, near Olympus Mons, we're going to see Valles Marineris, or the Mariner's Valley, and that is the longest canyon in the solar system. And if you were to put Valles Marineris on the Earth, it would stretch from southern Spain to Scandinavia. And if you were to put it on the United States, for example, for our international viewers, it would stretch from San Francisco to New York. So that is a mighty big canyon, much bigger than the Grand Canyon. This is a much grander canyon. Now, I mentioned those rovers, and we're pretty excited because there's one on the way right now, and that is the Perseverance rover. So this is an artist's concept of what Perseverance will look like on the surface of Mars. And you may notice it looks a little bit similar to Curiosity. If you remember the Curiosity rover, it's still working on Mars. Perseverance is a little bit bigger, a little bit heavier, and has some different tools. And this is actually a joint venture. The European Space Agency helped contribute to some of the tools that are on Perseverance as well. So space has really become an international endeavor, which is actually quite beautiful. So Perseverance launched in the summer and is on its way to Mars right now with an expected landing of February 18th. And we're going to go ahead and take you to see where it's going to land on the surface of Mars. Not too far from Valles Marineris. But we're going to head over now to the Isidius Planitia and take a look at Yazodo Crater. Now, you may have also heard this called Yazodo Crater, but Yazodo is how it is supposed to be pronounced. It's actually named after a town in Bosnia, so that is a Bosnian word. So as we look at this area, it's actually a really cool area to have a rover land. So whereas Curiosity landed in Gale Crater, which was a lake, this particular crater where Perseverance is going is actually had a river feeding into it, and the river left a delta there that we also have to study. So Perseverance has a pretty big job. It's being sent to take a look at not just the geography of Mars, but also really looking at the soil, and it's looking for biomarkers to see if there's any sign that there was life at any point in time. It's also going to be doing some dating of the area to see just how old the soil is and how that lines up in Mars's history, and can also be compared to Earth's as well. Now, another thing that it's going to be doing, looking forward to hopefully landing humans on Mars within the next decade or so, is it's going to be trying to package some of its soil samples for return to Earth. Now, whether this be in some way with a spacecraft at some point, or if it's humans actually going to pick it up, that's not yet been determined. But hopefully, one day humans will be on Mars working with that. Now, something else that's pretty cool about the Perseverance mission is that it has a helicopter attached to it. So this is the Ingenuity Helicopter, and it will be the first powered flight on another planet. So we've never had a powered flight before. The Soviet Union sent some probes to Venus and they actually had balloons in Venus's atmosphere. So that was the first flight on another planet, but Ingenuity will be the first powered flight. And so this is really just a test concept that tagged along with Perseverance. Its job is to see how well a helicopter could function. So within the first 30 days of the landing, it'll fly probably, well, hopefully at least once, but they're hoping for maybe 5 times. And they'll be doing some tests on how well it functions, as well as using it to maybe do some plotting of where the rover will drive. Now, the atmosphere on Mars is a lot thinner than on Earth. So it's going to be a lot harder for the helicopter to fly, or rather it's going to be a much different experience, particularly for any of you who may have flown drones. The helicopter's blades actually have to spin much faster to be able to get lift on Mars. Now, the Perseverance rover isn't the only thing that's heading to Mars right now. We also have a couple of spacecraft on their way to Mars as well from 2 other countries. One is the first ever from the United Arab Emirates, and that will be an orbiter. And the orbiter will be orbiting Mars to study the atmosphere. It wants to study what's left of the Mars's atmosphere. And this could actually be very helpful to us on Earth, because we know that Mars used to have a much thicker atmosphere, and it's been dwindling. And we're not sure why, but we depend on our atmosphere here on the Earth. That's certainly something we want to know if that's what we're looking for our future. So Mars really can be helpful to us on the Earth in seeing what our future holds. Now, the other one that's on its way is from China, and that's Tianwen-1. And it's actually 3 spacecraft in one. So there's an orbiter, which will stay up above, and it's going to arrive shortly before Perseverance does in February. All of them are going to arrive in February, but the rover that's a part of Tianwen-1 is going to wait a little bit. The orbiter is going to take some images and do some studies, and then sometime in late April, it's expected that the lander will head down, and in the lander is the rover portion of 1. So all of them carry that name. So yes, February next year is going to be a very exciting time to see what's going on with our rovers and Mars. And if you happen to be in the Berlin area, we also will be premiering an exhibit about Perseverance and Mars in February. So we're going to go ahead and zoom out a little bit more. And we're going to go take a look at what often is considered one of the favorite planets aside from Earth, and that is Jupiter. So Jupiter's a little further out. So what we looked at, Mars, Earth, Venus, and Mercury, are considered inner rocky worlds. They're inside of the asteroid belt, and they're all rocky. But Jupiter is a gas giant, and it's much further out from the sun. Now, Jupiter has a lot of moons. Jupiter has a lot of moons. As you can see as we enter, those are all the orbits of the moons around Jupiter. And what's kind of interesting with Jupiter is that it is named after the Roman god, king of the gods, so like Zeus in Greek mythology. And Jupiter's wife was Juno, which is like Hera in Greek mythology. And NASA created a spacecraft to study Jupiter named Juno and sent it out to him. Now, Zeus was a fan of humans and really liked spending time with them, more so than his wife often. And so all of the moons are named after the humans that Jupiter preferred to spend his time with. So NASA basically sent his wife to go check up on him. So what we're looking at now are these beautiful bands, and those are gaseous clouds. So we are looking at the clouds of Jupiter right now. And you may be wondering what that black spot is that we see coming just over the terminator, and that is the shadow of one of Jupiter's many moons. So Jupiter's moons were actually first observed by Galileo Galilei, which is why the first 4 moons are known as the Galilean moons. They are the biggest of the 4. And Jupiter is also well known for its storms. So we can see some smaller storms in the white circles that we see within those beautiful bands of Jupiter. But Jupiter also, of course, has the Great Red Spot, which is a hurricane or storm that has been raging on Jupiter for for over 300 years. It's been raging since Galileo was observing Jupiter. And that storm is so big that typically you can fit one to 3 Earths inside of it. Right now, it's about 2 Earths. That Great Red Spot actually does expand and contract as the storm varies. And every once in a while, people get excited because they think that the storm's going to come to an end, but it has not in the last 300 years. It's still raging quite a bit. We're also going to head out to Saturn, since that's another one of the popular outer worlds. Saturn, of course, is best known for its rings, but Saturn is not the only planet with rings. All of our outer worlds, so Jupiter, Saturn, Uranus, and Neptune, all have rings. It's just that Saturn's are the biggest and brightest and easiest to spot with a simple backyard telescope, making them more noticeable, obviously, and easier for even amateur astronomers to glimpse and take a look at and get to know. Now, Saturn is our second largest planet in the solar system, behind Jupiter, of course. And until very recently, Jupiter was also the king when it came to moons, but now Saturn is the king of moons with over 80. And as you can see, we see all those orbits too as we get closer. And now we can see the beauty of Saturn and its rings. And we can also see the rings do cause shadow effect on Saturn as well. Now, there's actually several ring systems within Saturn's rings, and that's why you see what looks like little grooves. Now, one of those grooves is actually carved by a moon. So the outer groove that you're seeing on Saturn's rings is actually carved by one of its many, many moons. So, and you may be wondering, well, how do we know that that's a moon and not just more debris? Because Saturn's rings are made up of ice and dirt and dust, and that the rocks and the ice can range in size from a particle as big as a speck of dust to the size of a house. So first of all, difficult to find the moon in there, but second of all, how do we know that that's a moon versus the rings? And mostly it's because it's spherical. So the moon is actually spherical, while the rest of it, the ice and the debris, looks more like rocks that you would find out in a little more jaggedy, not spherical in shape. We have 2 more planets left in our outer worlds. So we're going to do a quick flyby to visit those. Our next planet is Uranus, or Uranus, depending on how you prefer to pronounce it. And it is even further out, as you would expect. Now, Uranus and Neptune, you're going to see as we visit each one, they have a little bit different coloring than we saw with Jupiter and Saturn. They both appear bluish green. So Uranus appears more of that bluish green, a little bit more of a green tint to it. And you can see Uranus's ring system here as well. Uranus is sometimes called the sideways planet because it orbits on its side. Or rather, it revolves on its side. Its axis is sideways compared to what we would see with the Earth's axis, which is relatively perpendicular north-south. So the rings also look a little bit like they're sideways around our sideways planet, Uranus. And finally, if we head out to our last planet in the solar system, we're going to take a look at Neptune, which all of us here in Berlin love because it was discovered in Berlin. Neptune is much more blue. The blue and the blue-green come from the ammonia in the atmosphere. Scientists are still not quite sure why Neptune is a little more blue than Uranus, but hopefully in the future we'll have some missions out that way too that we can study their atmospheres as well. And I know some of you cringed when I said our last planet of the solar system. I know that we all feel for Pluto. We know that, first of all, Pluto is still a part of our solar system. We didn't kick it out. We didn't give it the Alderaan treatment. It still exists. But it is now better classified as a dwarf planet. There's 5 recognized dwarf planets at the moment in our solar system. However, we think that there may be thousands more out there. One of the dwarf planets is within the asteroid belt between Mars and Jupiter, and that is Ceres. But the rest of them are trans-Neptunian objects, so past the lovely Neptune that we're looking at here. And that's where the majority of the dwarf planets lie, including everybody's favorite Pluto. Now, looking at Neptune here, you can actually see a storm near the left side that's just about to go around. All of these outer worlds with the gaseous atmospheres, they all have the ability to have storms, just like we see with the Great Red Spot on Jupiter. But, of course, Jupiter is the one that is most well known. And as you can see, it's actually fairly calm on Neptune at the moment. Unfortunately, though, we're getting near the end of our time together this evening. And so we're going to slowly fly back to the Earth because we don't want to leave you out at the edge of the planetary part of our solar system. So one more view of our solar system from the outermost part. As we lock on to the third planet from the sun, our home, the only home that humans have ever known. And at this point in time, Earth is the only home that we have. It is the only planet that we know of capable of sustaining human life. There is no planet B. There's nowhere else that where we can go. What we have is our Earth. And we need to be taking care of this beautiful blue marble. It's quite fragile. It may not seem like it from day to day as we carry about our lives, but the planet's quite fragile, and we need to be doing a better job taking care of it. We need to be working together to solve global warming and the climate crisis, and hopefully protecting our Earth for generations to come. We had a question in the chat. How are they planning to bring the soil samples from Mars? That is an excellent question, and it's one that NASA has not quite answered yet. It's packaging them, preparing them to be brought back, but at this point in time, the hope is that humans will bring them back, hopefully within the next decade. But unfortunately, if we're not ready at that point in time, perhaps a robotic mission, I guess that's not unfortunate, but a robotic mission might better be able to collect those samples and bring them back for us. That was a great question. Thank you. So as we look at our Earth, I always like to point out that from space, we see absolutely no borders. This is what's called the astronaut effect sometimes. So as we look at our planet, we see no borders. All we see is land and water and clouds, of course. Beautiful view, and it really puts things into perspective. You see no borders from space. We're all humans. We're all in this together. And especially this year more than any other, that is something to take to heart. We are all in this together. We are not alone. And it's up to us to protect each other and this beautiful blue planet that we call home. So with that, I would like to leave you with this view of the Earth and thank you very much for joining us here in the Zeiss-Großplanetarium and our live stream this evening. Thank you for inviting me into your homes. I truly appreciate it. I hope you had a good time. I always have a good time with you all. And we are doing these live streams every week. Now, normally they're in German. It's a great way to practice if you're learning German. But we also do the Starry Night English live stream as well. So give us a follow on Facebook, Instagram, check out our website, and we will be listing the upcoming live streams that we will be doing from right here in the planetarium, from us to you in your homes. So with that, I would like to wish you all a pleasant evening. Thank you once again for joining us, and please stay healthy, stay safe, and take care of one another, and have a great evening.